Testing. All right, I'd like you to look again at your student data shared file, figure 3.8 on page 90. It's our account.h header file defining the class object account. Now we're going to trace our code today, and this is very important, a process that you'll want to undertake as you begin to design code and trace your own code. So this will be our tracing code example. So we have our class account, begin and end. Remember, this is a header for the definition of account object, class object, so it ends with the semicolon. I'm going to scan down to the private area where we are defining the class member data function, the class data members, which are, again, remember the std : is needed in our header files. As a string object, I have a variable name of name, and as an integer, I have the variable name balance, and I'm using the initialization process to initialize to 0. So what's happened, I've now assigned a class object of account, and visually I have my top component of my UML, and I'm defining the data members of this class object account. I have a private name variable, which is of type string, and I have a private balance variable, which is of type integer. I just made a note there that we're initializing to 0. Then as I continue to trace the code, I have my public. Here's my constructor. Remember, a constructor must have the same name as the account, as the class object account in this case, and class objects begin with an uppercase. Our standard STD, our constructor is expecting that a string is going to be passed to it from the driver program, and that string has a name internally of account name. I will be passing a string when I declare and instantiate my first object of type account. And the constructor is expecting an integer that will be passed and used within this body of code as initial balance. So let's make sure that we're updating our UML. I now have in the bottom compartment my constructor named account. I have a variable name of account name, which is going to be type string, and I'm going to have a variable name of initial balance, and it's expecting to be assigned an int value. In account.h, next we have a member function. It is public. It's the deposit function, and it's expecting an integer, and it's going to use a variable name of deposit amount within the body of this code. So we want to document that our account object knows how to deposit to itself. Here's our deposit member function. The variable name is deposit amount, and it's expecting that an integer will be passed to it. Next, we have our member function of int get balance. Remember that this is an example where we're going to be returning a value. No parameters are filled in the parameter list. Get balance does not expect anything to be shared to it. Get balance has the task of returning this account's current balance. So we see that we're only using one value that's going to be returned, so we use constant. and we're going to return a balance is going to be of type int. So we want to update our UML, get balance. It is public with the plus, and it's going to be returning an int that resides outside of trails, the get balance member function name. Next in our account, we have set name. Now set name is expecting that a string is going to be sent to it by, we're going to use a variable name of account name. So set name is public. It's a member function. We're using account name within the body of this code, and it's expecting that a string value is going to be passed to it. And then we have the get name member function, which is going to return a type of string. It only has one task to return one value, so we use the constant. And updating our UML, we have the get name method as public, and is going to return with the colon return a string. So after analyzing account.h definition file, we can now begin to trace what happens to each of these accounts as they're instantiated. Now we have class objects declared to be of type account with our definition of account.h. Remember that account objects, that class objects in general, carry their data members throughout their lifetime. So throughout this programming activity, account will know its current value for name and its current balance as an integer. So I have account 1, and my driver program is going to be declaring account 2. So my variable name is account 1 and account 2 in figure 3.9. In my driver program, and remember our convention is account test, you could name your driver program account driver. It's just by convention that we use account test. It correlates then to the account object. We would also have to make sure that we're including our account class object definition with the include pound sign include within double quotes account.h. In our CPP source code, we can abbreviate using namespace std as a directive, so we don't have to type the std in our source code for .cpp. So I have my int and my closing for the main. I'm going to instantiate a new variable, account1, by the name of account, and that is going to call our account constructor. An account constructor is expecting a string, while we're sending a string. Within quotes, we have Jane Green. So now account name is assigned Jane Green, and the constructor is expecting an integer to be sent, and we're passing 50 as an integer, and that will be assigned to initial balance. So we have Jane Green and $50 assigned in the account 1 object. So name is assigned account 1, which was passed as Jane Green, and in our driver in the account.h, we test if initial balance, which was set 50, is greater than 0, then balance, which is the data member balance of account 1, is set to 50. Back to our driver program, we're going to output. Oh, we're also going to assign account 2. So I have account 2 as a variable name for a class by the object by the name of account. I'm passing John Blue and a -7. So I'm calling the account constructor. I'm passing account name as John Blue and an integer balance of -7. Name is assigned the account name that was passed to account.h, which is John Blue. And we passed a -7 to our constructor, but we're going to validate that initial balance. It has to be greater than 0. We can't deposit a negative value into an account. If initial balance is greater than 0, then we're going to assign balance to initial balance. If initial balance is not greater than 0, nothing happens. And remember that we had initialized balance to 0 as a data member in the initial construction and instantiation of the account object. So nothing changes for John Blue. He cannot deposit a -7, so his balance is still 0. Well, then we're going to do some printing out. Enter deposit amount for account 1. Well, let's enter a deposit amount on page 93. We're going to enter $50 for Jane Green. So let's enter $50. We see in $50, we're adding $50 to account 1 balance. And then we call account dot deposit. Remember, to get into each account, it's account dot, and then we want the balance method. So we want to account dot deposit, and we want a deposit of an amount. So we're going to call deposit, and we're sending a deposit amount of 50. If the deposit amount is greater than 0, it is, so our balance is going to be equal to, well, Jane Green's balance was 50. So we're going to print that amount. Account 1 deposit dot deposit amount adds that amount to account 1 balance. So it is now 50. We're going to check the balances. Account 1, account dot get name. Well, get name would be Jane Green. Balance is account 1 dot get balance. We need to get the balance for account 1. Account 1 knows its own balance, so it's going to return 50. And get account 2's name, which is John Blue, so we'll print John Blue. And balance for John Blue is, remember the $sign is output now, account 2 dot get balance. And account 2 dot get balance is going to return account 2's dot current balance, which is 0. So we see our first pieces of output. We deposited $50 into Jane Green's balance. 50 plus 0 is 50. And we are just showing that we haven't deposited anything in account 2 yet. What is the current balance for John Blue? It would be 0. Next, we're asked to enter a deposit amount for account 1. So let's add 25. Go back to our driver program. Enter deposit amount for account 1. We're going to enter 25. Deposit amount, adding deposit amount, 25 to account 1. We're going to call account dot deposit. Account 1 dot deposit. And our deposit method expects an integer to be sent. So we're sending deposit amount, which is 25, account dot deposit 25. So with account 1, we're going to deposit 25. If it's greater than 0, that's great. Balance. Well, balance is currently 50 for account 1, is equal to 50 plus the deposit. And we're adding 25, so we'll now have 75 in Jane Green's account. We're going to display those balances. Display account 1.getName. Well, that would give us Jane Green. Balance is account 1.getBalance. And account 1.getBalance, account 1's current balance is 75. So enter a deposit for account 1 of 25, adding 25 to account 1's balance. Jane Green's account is now $75. And we're just going to confirm that John Blue's balance is still 50. We haven't done anything with John Blue. Now we're going to enter an amount of deposit for account 2 of $123. Enter deposit amount for account 2. Prompt your user, and they're going to type in 123, I guess is the example in the book. We're going to add 123 to account 2. Account.2 deposit, and we are sending 123. Account.2 deposit. So with an object in hand, account.2, we're going to call its member function deposit. I'm sending 123 as an integer, and member function in the header, deposit, expects that 123. It is greater than 0, so balance for account 2 will be its current balance, which is 0. John Blue, account 2 is 0. And I'm depositing a value of 123. So it overwrites, and it's now 123. Now I want to display these balances. Account 1, get account name. Well, that's account 1.getName, returns Jane Green. Balance is account.1 get balance. Account 1's current balance is 75. And account 2.getName. Account 2 knows its own name is John Blue, so it's going to print John Blue as a string. Balance is account 2.getBalance. Account 2 in the account header, get balance. Get balance returns the current balance of account 2. Account 2.getBalance. Each account knows its own data members' values at all times. So it returns, and account 2's current balance is 123. So it returns 123, and we get our final lines of output. Jane Green balance is still 75. John Blue's balance was increased to 120. So this is tracing the code between your account header file that defines the class object of type account and making use of the account objects that we instantiate in current memory. And in this example, we instantiate 2 objects of type account 1 and account 2, through our driver program. Again, this process of sketching your UML and tracing what happens to your account data members' values as we continue to process the driver program is very helpful and beneficial for understanding the logic as well as tracing any errors. So thank you very much.